Hi everyone, in this video I will going to solve this algebra equation. The equation we have x root of x plus root of x is equals to 10. Here we need to find out the value of x. So let's get started the solution. Here we have the root of x is common. So here I will going to let root of x is equals to n. And if I want to find out the value of x here, so I'm going to take here square root this side. This and this get cancelled. X is equals to m square. Now here I'm going to plug in the root of x value, that is m, and the x value, that is m square. So this equation turns to m square times m plus m is equals to 10. Next, I was going to take this 10 to the left hand side, and this we have 1 power, so it will be equals to m cubed plus m minus 10 is equals to 0. Next, I am going to split this 10, m cubed plus m minus 8 minus 2 is equals to 0. Next, I will going to write this 8 in the form of power. So this will be equals to m cubed plus m plus minus 2 to the power of 3 and minus 2 is equals to 0. Next, I will going to rearrange the same power together. M cubed minus 2 cubed plus m minus 2 is equals to 0. In the next step, I will going to apply here the algebraic identity, that is a cubed minus b cubed is equals to a minus b, a square plus ab plus b square. So here we have the a and b value. So this equation turns to m minus 2 m square plus 2m plus 4. Now this plus m minus 2 is remaining is equals to 0. Now next I'm going to take common factor of m minus 2, m minus 2, where this whole expression is remaining, plus 4, and this we took the common, so here 1 is remaining is equals to 0. And this will turn to m minus 2, m square plus 2m plus 5 is equals to 0. Here we get the two cases. M minus 2 is equals to 0, and here m is equals to positive 2. And the other case we have, that is m square plus 2m plus 5 is equals to 0. So here we get the quadratic equation. The a value we have here, that is 1, and b we have 2, and c we have 5. Now we're going to plug in the ABC's value in our quadratic formula here to find out the value of m. M is equals to minus b plus minus root of b square minus 4ac over 2a. M is equals to minus b, we have positive 2 plus minus root 2 to the power of 2 minus 4. A we have 1 and c we have 5 over 2, and a we have 1. This will be equals to minus 2 plus minus, and 2 to the power of 2 is equals to 4 minus 4, 5 times is 20 over 2. And this will be equals to m is equals to minus 2 plus minus 4 minus 20 is equals to negative 16 over 2. And here I want to separate this negative sign from 16. So m is equals to minus 2 plus minus root of 16 times negative 1 over 2. The next step, I will going to apply here the radical property, that is n root of a times b can be written as n root of a times n root of b. M is equals to minus 2 plus minus root of 16 times root of negative 1 over 2. And here we'll get M is equals to minus 2 plus minus root of 16, we have that is 4, and root of negative 1 is equals to iota, the imaginary number, over 2. Now in the next step, I'm going to take here the common factor of 2. M is equals to 2 is common, minus 1 plus minus 2 iotas remaining over 2. This and this get cancelled. So here we get the two M values. One is positive, the other one is negative. M2 we have that is minus 1, positive 2 iota. M3 we have minus 1, negative 2 iota. Now here in the next step, I am going to recall root of x is equals to m. Now here I'm going to plug in the m1 value. Root of x is equals to the m1 value we have 2. Now I want to remove here the root, so I am going to raise square both the side. This and this get cancelled. X is equals to 2 to the power of 2 is equals to 4. So here we get the first x value, that is 4. Now I will going to plug in the empty value in the same expression. Root of x is equals to m2. Root of x is equals to m2, we have that is minus 1 plus 2 iota. And now next I will going to raise square both the side. I will going to rearrange. This and this get cancelled. Here we get x is equals to, here I will going to apply the algebraic identity, that is a minus b whole to the power of 2 can be written as a square plus b square minus 2ab. So here we have, this is our a and b value. So I will going to write here 2 iota whole to the power of 2 plus 1 square minus 2 and 2 iota and 1. And this will be equals to 2 iota 2 to the power of 2 is equals to 4 and iota square plus 1 minus 2 to them give us 4 iota. Now next we know that root of negative 1 is equals to iota. Now I want to plug in the iota square value. For that I'm going to raise square both the side. This and this get cancelled, where we get negative 1 is equals to iota square. So the value we have, that is negative 1. X is equals to 4 negative 1 plus 1 4 iota. And this will be equals to minus 4 and minus 4 iota plus 1. This and this is going to be turned to negative 3 negative 4 iota. So here we get the complex solution because of the imaginary number we get here. Now we're going to plug in the m3 value in the same expression. Root of x is equals to m3. The m3 value we have here, that is root of x is equals to minus 1 and negative 2 iota. Now I will going to raise square both the side. Here we have the negative sign, so I'm going to take this out and I'm going to write 1 plus 2 iota and whole to the power of 2. So here this will going to be cancelled out. X is equals to, this will going to the positive 1, and here this will be equals to 1 plus 2 iota whole to the power of 2. Now here I'm going to apply the same algebraic identity. This is our a and b value we have. X is equals to 1 square plus 2 iota square plus 2 and 1, and b we have 2 iota. And this will be equals to 1 plus 4 iota square and plus 4 iota. And in replacement of iota square, we're going to write -1. X is equals to 1 plus 4 and -1 plus 4 iota. X is equals to 1 and plus minus 4 plus 4 iota. And here this will be equals to -3 plus 4 iota. Get another complex solution. So this is the final answer. Thank you so very much for watching my video. If you like my video, please do subscribe to my channel